And again, welcome to today's webinar, Getting Started with AWS. Our presenter today is Miles Ward, Senior Solutions Architect Manager with Amazon Web Services. Miles, you have the floor.
Anna, thanks a bunch. And everybody on the webinar, thank you for taking time this morning. I'm excited to walk you through what are a lot of folks' very first steps with using what we believe is the platform of the future, the cloud, AWS. What I'm hoping to do is walk through a pretty simple explanation of what it is that AWS is and does, talk to you a little bit about the value proposition of this set of tools, and then dive right into a step-by-step demonstration of getting your first AWS EC2 instance running, connecting to that instance securely. I'll show you a little about EC2, a little bit about S3, and then open it up to your questions. Make sure that these first steps are ones that are really understandable and something that you can take with confidence. So without any further ado, the cloud computing platform called AWS offers really a very complete set of values. We set out at the very beginning as a subsidiary of Amazon.com, seeking to be Earth's most customer-centric company. We listened to IT buyers and developers and systems integrators and consultancies, all the way down to somebody who just wants to save a file on the web. And we listened to them and built a set of services, not that were designed around a set of technical requirements or specifics around performance or any of that. We wanted to build a set of values. And those values had to do with solution completeness. We wanted to make sure that you could really do things with our platform. So we've built, and I'll walk you through, quite a few different services that make it really easy to build online and offline systems that are very high performance, that are very secure, that are very cost efficient, that are very agile. We knew that flexibility was pretty paramount in that folks wanted to be able to grow and shrink their actual systems around the workload that was presented by users or customers or even their internal projects. We know that companies aren't just in one state or city anymore, that they have an urge for a global presence, that there's a global market out there, and that being able to deploy the same kind of solution in Singapore that you can in San Diego is a pretty spectacular pattern. We also knew that none of this stuff happened fast enough, that all sorts of business opportunities and business value were available if you could have instantaneous access to resources. So many business opportunities are gated by how fast you can get something done or can you meet this emergency need. We knew that being able to deploy immediately was super, super important. And we knew that cost was a massive driver of the way that businesses made decisions and users make decisions about how things work. We're again, a child of Amazon.com, and we know that every time we can lower the price, it's good news for us and for customers. We also know that this combination of values should work together to make even the smallest development teams pretty staggeringly productive, that you'd really be able to get an incredible amount of work done if you had something that was flexible, that was globally distributed, that was instantaneously accessible, that was super, super cheap, and really presented a very complete set of services. So the tools that we've built really focus in around a series of basic benefits. We want to help users avoid that undifferentiated heavy lifting. What does that mean? So, many different companies all need compute and storage and database resources, but those resources are really basic and uniform in many ways across lots of different kinds of users. A computer for running the business of a laundromat isn't really any different than a computer for running the business of a space station. And so making it so that all of that undifferentiated work, the basic stuff, turning a computer on and installing the operating system and racking and stacking it and making sure that it's connected to the internet and making sure that it has a firewall that works, those basics, they don't differentiate a business. There isn't anybody that's in the laundromat business that says our competitive edge is based on being able to rack and stack computers better and faster. So because of that, we've worked really hard to convert what was a commodity type of product, the ability to buy a computer on the open market and deploy it and manage it, into a utility type of market, one where you're able to pay only for what you use. So we know that it's built around this concept of capacity management. So if you're back to that laundromat, you may think that you just need the one big server to run your website and everything works fine, but then all of a sudden everybody's clothes get dirty all at once, and now everybody goes to the website all at once. It's really hard to guess in advance how much of a given utility resource you're going to need. It's even worse when it's a commodity where you have to buy them a piece at a time. So you can imagine, you either have one of two options. You buy too much, which is the case in a lot of businesses where they'll over-provision, where the utilization of what they purchased is historically very, very low. Or you under-purchase, and all of a sudden, wow, you're out of stuff, and you're scrambling to make sure you turn on enough gear, and you have to wait for shipping and procurement and delay, all of which doesn't do anything to increase the cost, but certainly decreases the value of the IT service that you deliver. We also, as we've said before, we really wanted to drive prices down and being more efficient about that capacity assignment. If you didn't have to guess in advance, if you could deliver resources on demand, in fact, programmatically using software, you wouldn't have to be picking 6 months or 9 months in advance how much gear you knew you were going to need. And as a result, you'd be able to use just the bare minimum at any given time. That's so much more efficient. It absolutely has to drive the price of things down. We also know that that combination reduces the risk of investigating or experimenting in some kinds of new business opportunities. If you have to buy 20 computers and set up a rack and get a colo facility set up and have an IT guy full-time making sure all that stuff works, you may not go do an experiment. You may just elect not to try this new business unit out. If you can experiment on AWS in pennies for the use of some smaller of our resources, you may experiment a lot more often. You may be able to get into market more quickly. You may be able to capture new opportunities in a way that's difficult otherwise. So I keep talking about the cloud thing. What exactly is AWS? So AWS is a system for deploying infrastructure as a service. So that infrastructure starts with a series of data centers deployed around the globe. A data center is just a big warehouse full of computers, and Amazon knows a thing or two about warehouses. So we have a whole bunch of warehouses all over the place, designed to the highest standards of security and durability in order to be able to deliver a series of resources above those data centers. So we continue to add them all the time. We have them now in 10 different regional clusters around the world. Those different regions themselves are made up of availability zones, which you can think of as one or multiple of these warehouses in a small area. Those availability zones allow you to build at low cost an application which is distributed across multiple facilities. That single design bonus, being able to do that at relatively no additional cost, you're able to build systems that can survive total data center outages. Really powerful addition. What's required to make something like that work is a really outstanding networking system. So AWS has invested in an incredible system of networking that happens automatically as a default, as a totally normal part of what's built. You need to move terabits a second of data to the internet. We are ready to do that. You don't have to ask anybody nice. You just stand up the equipment required to do so. So above this incredible global infrastructure and a networking stack that allows you to leverage that infrastructure, we built what we believe are the basic primitives, the simplest components required to stand up any kind of online system. One, you need compute. You need storage to keep your data and to keep your databases and keep your applications. And then you need structured storage or database storage, either in the relational style like a SQL Server or MySQL, or in the NoSQL style like DynamoDB. We also heard from customers that there's a bunch of, remember that word, undifferentiated heavy listening, there's a bunch of the same kinds of software services that get stood up no matter what you really need the individual application to do. So, for example, lots and lots of well-designed systems have a queue, have a loose coupling device called a queue. And you can stand up a queue in numerous different pieces of software, from very sophisticated enterprise service buses all the way down to little simple workflows. We built a queuing service. So instead of having to dedicate whole computers or EC2 instances to the queuing effort, instead we just rent individual in-queued messages from us at incredibly low price. And there are dozens of other services that simplify the process of building better applications, more resilient, more durable applications. We also heard from customers that it was one thing to have all of these building blocks, but it was another thing to make them easy to use and make them easy to administrate. So we'll look at a couple of the deployment and administration tools. One of them is called the Management Console. We're going to look at that quite a bit. But there are also tools like CloudWatch for monitoring and CloudFormation for templated deployments of your infrastructure, or OpsWorks for stack-based deployments of infrastructure. Lots of stuff that make it simpler and simpler and simpler in order to be able to deploy these kinds of applications. So the nice bit is that none of this stuff, right out of the gate, a very tiny number of our services don't support a thing called the free tier. So most of the AWS services include a little bit of usage for free so that you can learn our interfaces, you can learn the strengths and limitations of our systems, you can try out your application running on top of us in a way that shouldn't cost you a dime. We're going to do some demonstrations today that show what the free tier looks like, and all of the stuff that I'll demonstrate today you can do at no cost for a whole year on AWS, which is a pretty great deal. So what we're going to do from a demonstration standpoint is pretty simple. I'll walk you through the beginning of setting up an AWS account, which is a pretty simple process, same as signing up for lots of different online services. And then we'll create a security key, a thing called an SSH key. That's an encryption tool used to log into EC2 virtual machines, or instances is what we call them. We'll also create a security group, which is a fancy name for a more flexible kind of firewall that's used to secure and permit access to and from your local working machine, say the laptop or desktop at your house, into the machines in the cloud. Then we'll create one of those virtual machines, we'll log into it, we'll mess around with it for a little bit. Following that, we want to make sure that as you experiment with the free tier that you're able to understand what it looks like, not only to see that instance do a bunch of work, but also maybe to set an alarm around whether or not you stayed inside that free tier. So we'll set an alarm for you so that you get notified if you start some stuff that's going to cost money. We'll also back that instance up. We'll show you how easy it is once you're operating in a virtualized way, in a cloud way, to take an instance and secure it and back it up and make sure that you'll never lose those bits. And then we'll compare and contrast that to S3. S3 is a storage service for the internet. And we'll talk about what that does and how it works and what makes it work. So let's talk about signing up in an easier way than just going through the slides. I'll show you what it looks like. So this page here is aws.amazon.com. Make it a little bigger so it's easier to read. So aws.amazon.com is our portal into using the AWS services. If you've never used them before, you click this little button, pretty obvious, called Sign Up right at the top. And when I click to sign up, it'll say, okay, I want to call and make sure that you're a real person. This is an old phone number for my Amazon account. Now, my browser is already logged in to Amazon.com, and so this system's already trying to sign me up with an Amazon.com, my commercial account, the email address that I use to buy, computer parts and toys from Amazon.com. So an important tip, you should always use an email address that's different than your Amazon.com commercial email address. So make a new Gmail account, or make a new account at your corporation, or or any other sort of domain that's just for the purposes of being your AWS credential. When you log into AWS through the sign-up process, you'll put in your email address, your name, your address, and then this is really the second step, where it will ask to verify that you really are who you say you are by phone. And they'll call you, and if that works, then you'll go on to this next confirmation step. Once that part is done, back here at aws.amazon.com, you'd be able to log in to what's called the Management Console. Management Console is one interface to being able to interact with all of the different services that I talked about. Now, there are other interfaces. If you're a software developer, you might log in using our SDK, and there's a lot of detail about that right here in the Developers tab. If you're a remote application, you might just talk directly to our API. And there's a lot of information about that in our product and solution detailed user guide. But for a manual user, someone who's just going to go click, point, and click, you go here to the Management Console. I'll click a button on that, and we'll log in. So this is the Management Console. You can see all of the different products that are administratable by way of the Management Console available here. So there's a lot of products, and I don't want you to feel like you have to know everything about every single one of them. If you aren't ready to go build a real-time processing stream on Kinesis, that's okay. There isn't anything on our side that forces you to use any tool other than the ones you want. So the first tool that we're going to use is called EC2, the Elastic Compute Cloud. And that's over here. That's probably the most basic piece of AWS, is turning on a computer so you can do some stuff. But there are some things we need to do first so that we can access that computer in a secure way. So when I click on EC2, I see this dashboard of what's going on. You'll note in the upper right-hand corner here, I'm logged into Oregon. So the Oregon facilities are ready to use for EC2. If you click on this, you can see there are numerous other regions that I could select to build the same kinds of infrastructure in. But each region is logically distinct, so things like this SSH key and other pieces we're going to build, they are distinct across regions. So the first step, if I'm going to get started and I want to get my hands on a virtual machine, is I create a new key pair down here in this little button in the left-hand corner. And there's a couple keys. I have this awesome demo awesome key, and I have an Oregon key. Let's make a new one called Super Awesome Demo. And that way we know which one it is, called Super Awesome Demo. Now you'll note it download. Little security point of note. This is a private key, public key, key pair. Right? That's why it's called a pair. And so inside the browser, the encryption work has been done to create my side of the key, the private key. And AWS has held the public key. The public key is used to encrypt access to the EC2 instance. So only someone who has this key, notably me, is able to get in and use a virtual machine. So now we have a key pair. That's good. The next step, before we even start a virtual machine, we might want to create a security group, a way to ensure that that instance is protected, right? So there's a default security group. You're always going to want to create a special one just for you. And we're going to create security groups inside of VPC. VPC is called, what it means is Virtual Private Cloud. VPC, in most cases, for your account, if you create a new account today, is the default. So you wouldn't have the little pull-down selection like I do on my screen. Old accounts have both options. But for new users, everything should happen inside of VPC. VPC gives you better network control over the configuration of your EC2 instances. So let's call this one Demo Today account. And it needs a description called For My Awesome AWS Friends. And I created it. So this security group is a VPC security group. So you see it over here. There's a couple different ones here. Here's Demo Today. So this has a weird ID number, which you're not going to need to memorize. And you can tell which one it's for. It's For My Awesome AWS Friends. So to start an EC2 instance, I'd go to the Instances tab. Now if I click on this, you'll note there's some old ones that I was working on here that have been deleted. In a brand new account, you won't see anything at all. To create a new instance, you click on the big blue button that says Launch an Instance, and that takes you to a wizard. And the wizard has several steps. You can see them across the top, all the different stuff we're going to do to create and correctly configure an AWS EC2 instance. And the first part of that is figuring out which operating system the instance is going to run. So you could choose Red Hat Linux or SUSE Linux or Ubuntu Server. You can choose Amazon's native distribution of Linux called Amazon Linux. If you're a Windows user, you could start a Windows 2012 or Windows 2008 R2. You can even start some EC2 instances with software pre-installed, like this Windows server has SQL Server Web pre-installed or SQL Server Standard pre-installed. Any of the instances here that are available for the free tier, you can click the little free tier button, and you'll see which ones are free tier eligible, right? So we want to use one of those. I'll use Amazon Linux because I work for Amazon. It makes total sense. If you hit the select on that, then it will show you the different kinds of EC2 instances that are available for running that operating system on. Now, I chose the free tier, so it shows me this T1 micro instance, and that's available for free for a year. Really a cool benefit of using AWS. But there are lots of other instance types. So you have virtual machines all the way up through M3 2 extra larges with 8 cores and 30 gigs of RAM. That's what that shows on the screen. You can go to memory optimized instances that are 8 cores and 68 gigs of RAM. You do storage instances with 48 terabytes of local hard disk, all sorts of crazy stuff. Compute optimized up to 32 cores and 60 gigs of RAM. Now, all those instance types, they have a cost associated. For our experimentation in the free tier, we'll stay here on a T1 micro. And the next one is to configure the instance details. Now, I only want one. You could certainly start 10 of them if you wanted. That's the joy of the cloud. But instead, I'm going to start this inside of VPC, and that's a default for most of your accounts. In VPC, you get to select the IP address range. So I'm going to start an instance in this 192.0.1.0/24. What /24 means is a CIDR range, CIDR notation. CIDR is a way of assigning how many addresses after the number that gets shown you'll be using. So /24 says the next 251 IP addresses, really. Some of those are withheld for our networking use. We also probably want a public IP address assigned to this instance automatically because we're going to want to be able to get to it and mess with the thing. We're not going to need an RAM role, but if you wanted to know about it, what that does is pushes AWS credentials down to an instance so that it could take actions on your behalf. Imagine a computer that turns on, that runs a piece of software that actually tells AWS to turn on more computers when it needs extra. What a cool feature that is. So you also, if you shut down the instance from inside, if you tell it to run the shutdown or turn off or reboot, what's the behavior that's going to happen on EC2? We want that to be stopped typically. And are we going to run this in the typical, very standard shared tenancy way, or the much more expensive and typically not used, only really for regulatory compliance, dedicated tenancy way? So there at shared tenancy, the next bit would be to add storage. And we're actually going to do this as a second step. Right now, we're just going to launch it with this original 8 gig volume, but we'll go back on and add a bigger one later. If you wanted to add one now, you could say, I want to add an 80 gig drive, or I want to add a 32 gig drive, or whatever. And you can make it run either standard EBS or provisioned IOPS, where you can configure it all the way up if I make the drive big enough. Let's make it a terabyte in size. Now I can run this thing at 4,000 IOPS if I want. I can do that down to, say, 135 gigs, and I'll still keep that 4,000 IOPS. But I don't need a high-performance EBS volume to be able to demonstrate a little web server today, so we're going to make this much smaller. Call it 32 gigs, just fine. The next thing we can do is name it. So we can add tags, like, for example, this is the server for cool people. And I might also create a tag like, business department cool people. And we might also have, like, production status. Demo, not ready for production, hasn't been validated by our internal. Then you'll assign a security group, next bit. So we can create a new security group if we want, or we can select an existing one. Now you remember we made one before, so we'll pick this demo today. And you'll note the security group has no rules. That's for something we're going to show here a little bit later. So let's review and launch, and it'll say, hey, you can't really get to this virtual machine. You didn't make any rules in the security group that would allow you access. So that's an important message. We probably want to say, well, I don't know if I want that one. Maybe I'll go back and change the way the rules work. Let's create a new security group instead. Let's call it Better Demo. Works better this way. So the first address we want to be able to permit in a security group is probably port 22. That's so that we can SSH into the instance. We probably also might want to add things like HTTP access. Let's do that. Say, well, I want to be able to get in there by the internet. And so let's open up 80 to anywhere in the world. Now, for SSH, what we may go in is open this up only when we want to do work and then close the port. Or we may open it only to my specific address. So if I say on my dear friend here, what is my IP? If you look, this is my IP address. So I can take that and put it over here and say, no, not the whole internet. How about, whoa, wrong button. Go back to EC2. So the backspace key backed me up in the browser, so I'll show you going through the wizard a lot faster than I did the last time. I want to do VPC, please. Give me an address, please. There we go. And then take this one out. And then we'll add HTTP to anywhere. There we go. So now, if we look, here's the EC2 instance. Here's the security group we configured. Here's our little storage. See, we didn't put on an extra disk, so we'll go add one of those later. And we have the tag where I named it awesome. So then we launch it. It'll say, hey, now hold on. You need a key pair to be able to access this thing. We made it. It was called Super Awesome Demo. There it is. And I say, yes, I actually have Super Awesome Demo. And now it'll go through the wizard of actually launching the virtual machine. So I can watch a log of the operations of it launching, and this is the instance ID that's created. Now, it takes us a minute for it to boot, but there's an interesting thing here. It says, get notified of estimated charges, where you might want to get, say, a billing alarm that would let you know, at 366 days when you start accruing that 2-cent an hour charge for running this T1 micro. So let's go build a billing alert that would allow us to get notified when we start actually creating charges. Now we're in my AWS account, and it says to me, hey, to get started using billing alerts, you're going to go into your account activity panel and take a look at what your billing preferences are and what your activity configuration is. So there's a bunch of different options here in the left in your account around configuring your alarms and your payment system. Now on the account activity page, you'll also see each of the different billing alarms that have been created. Now, if you have a new account, you don't have one. And the nice bit is that you can use the billing alerts at no additional charge because you get 1,000 free notifications a month and 10 free alarms as a part of that free tier. So if I go over here to, say, billing preferences, it has a whole bunch of different items that I can turn on. So I have my monthly report turned on, my programmatic access, so I can get my bill out of S3, how a detailed billing report, all these different things you can turn on to get really great information about how your account is being used. I can also go to the account activity page and see a summary now of what my spend has been on AWS and how that's working out for free tier accounts. That's going to end up showing, hopefully, as a big donut where you're not spending any money at all. Mine, if I go to the preview of the billing console, which I think you'll like, shows a lot more detail about stuff being used. So I've spent about $3,000 this month demonstrating and demoing and testing. I've used a little Redshift. I've used developer support. I've got a couple other services going. Really, EC2 and Redshift dominate my cost. But your bill should look a lot more like a zero. So if I go back to over here into CloudWatch, which is what it talked about, would be a good place to create that billing alarm. So it says right now I don't have any alarms, I don't have any metrics, I don't have anything going on. So let's create a new alarm. Click that button over here. And I say, well, I don't want those metrics. I want the billing metrics. Let's browse through the metrics. Click, click. Oh, I don't want any of those. On lunch. I want them in North Virginia, sorry. So let's create an alarm. And here's the billing metrics up here, right? So I'd say I want a metric, I want to create an alarm off of total estimated charge. So here's my estimated charges in USD. And you can see it going up over time as I use more and more services. I'd be able to build an alarm off of this if I was selling it. I'd say, well, okay, I want to use USD as my alarm. I want to be like, whoa, spending dollars. Now, right now, I actually spend quite a bit on a monthly basis. So I might put in, send the alarm when I spend more than $5,000. So you can see my threshold is up here and my blue bar is here. If you have a free tier account, your blue bar should be down here at 0. So you might put this at spending greater than $1. Now, if I put it for $1, my alarm will go off right away. So I'll put it up here at 5,000. Now, another thing is that I can do is I can say, I want to send a notification. I could create a new notification. And the email list that I want to send it to, send notification to good people in the demo. And the email list would be, awesome folks at awesome. There we go. So you can set as many of these notifications as you want, and then you hit create alarm to go do it. And it will set that alarm up. And then you'll be notified whenever it is that your cost has exceeded this threshold. Okay? That's pretty fun. And I'll go through and create the alarm, and there it is. And I don't have enough data yet because the email address hasn't been confirmed. So when I actually send an email to awesomefolks@awesome.com, then the alarm will be turned on. It probably won't work because awesome.com isn't answering my email. So if I go back to EC2 and go back to look at this one instance, I search, there it is, already up and running. So that EC2 instance, we actually see quite a lot of detail about it. You scroll down in here and you see all sorts of stuff. It's private DNS address, it's internal private IP address, it's external public IP address, a whole bunch of other stuff. If I grab this public IP address, let's go take a look. You could just try and go to the web and it'll be like, no, hold on a minute. We don't have any servers running, we don't have anything turned on this virtual machine. That view isn't going to work. How do we log in to the computer? Now, you'll note this oh so convenient connect button right here at the top. And what it says is, well, you're going to need to change the key into a format that can be used to log in to computers to secure it a little differently. And then you'll use SSH to log in to that server. Well, let's do that. I go here and say, give me a terminal. But I don't like that color terminal. I want a cool looking terminal. Let's call it that kind of terminal. Oh yeah, nerd terminal. So if I go to the Finder, and here's the download folder where I downloaded my key. So if I go here, I do that schmod 400 on super. Now the key is ready to be logged into. If I go back over here, I say, hold on, give me this sample. I want to use that because I don't like typing. It'll say, hey, are you sure you want to connect? And I say, absolutely yes. So there's the little EC2 logo. We are now connected to the instance. If I look at, there's, probably here it says there's a bunch of security updates. So let's do those. Sudo yum update. It'll run off and connect itself to the internet and download 88 megs of stuff. That's kind of a lot. chew, munch, 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 chow, chow, chow. So the computer's pretty good. It's connected to the internet in a pretty incredible rate. Pretty high performance computer for something that you get for free. And it'll go through here and do all of the installations required to provide a secure and well-configured virtual machine. Now if I go back over here to EC2 and our console, you can see the instance also passes a couple of status checks. We know that it's working. It also is being monitored. So it has a CPU utilization, disk reads, disk operations, disk writes, networks in and out, any status checks that have been failed, any of those. So right now, we're only updating this data every 5 minutes. So in a couple of minutes, you'll see a new data point pop up where our virtual machine is probably doing a little bit of work because it's running off and updating itself. So if the computer's on, and I go to this address, I still don't get anything, what's going on? Well, it probably means that there's no web server installed or set up on the virtual machine. So we'll have to do that as the next step to make sure that, that we're able to actually do any kind of useful work with the thing. So if I go back over to the EC2 console, the security group part, if we go over here, if we look at the description of the instance, it says that it's using this Launch Wizard 3 security group. And if I click on it, it is open for port 80 to the world. That's what you'd need to be able to look at a virtual machine. So another view of the computer is to look at what's its hard drive. So here at dev SDA1, that's this volume number for the EBS volume. If I go to Elastic Block Store here on the left and click on volumes, if I click on that, you'll see the actual volume. Here's the 8 gigabyte hard drive we created in US West 2B. That's the root drive. See, you can see here it's attached to the computer called Awesome in the position SDA1. If you wanted to create a new volume and attach it to that virtual machine, you can do that from here. So instead of having to do it at startup time, you can do it after the fact. So you could say, I want to create a standard volume. Let's make it, how about 27 gigabytes? That sounds fun. And it has to be in the same zone. So here it says US West 2B. I'd say US West 2B and attach that to the virtual machine. So now it'll go through and figure it out and click, click, click. It gets created, but it hasn't actually been attached to the EC2 instance until it's done this process. So now it's available. I want to say on this volume right here, just this one, I want to attach the volume. It'll say, hold on a minute, which computer do you want to attach it to? I say, I want to attach it to the Awesome one. And then they'll ask you which drive letter it wants you to do that to. Oh, I want to do that to the F drive. That sounds great. Sure. And it'll go off and do that work. So see, it's already attached, ready to go. I go back to the terminal. So now we're done doing the Yum update. Maybe I want to do Yep, give me Apache. So then it goes off and gets a web server, and then I say, so now it says that I've started the Apache browser. Well, let's go back and take a look at our IP address. Voila, Amazon Linux AMI test page. So this is to test proper operation of HTTP. The web server is working. If I went back to the EC2 instance and said, no, stopping HTTP, I come back over here and I reload, it doesn't work. So that's one way to connect a computer to the internet and to get files, and that little file is a little HTML file that we saved online. But there's lots of different services from AWS that allow you to do that same thing. Let's take a look at a different one called S3. Now I had to create a virtual machine, I had to connect to it, I had to download. What if I'm just trying to save a simple little file to S3 to make it so that it's only available on the web? So this is S3. I have a whole bunch of different buckets. Buckets are containers for files that can potentially be connected to the internet. So let's create a new bucket, and we'll call it Supremely Awesome Demo Edge. And I will create it. And it'll say, oh, no, gotta have lowercase characters. Can't name it some silly thing. How about Supremely Awesome Demo Creation? Even better. Create. So it creates this incredibly long name for a container of files. If I click on it, there's nothing in the bucket. It says the bucket is empty. Let's upload a file. Let's say, well, here on the desktop is the logo Precious. And I think the logo is, yep, that's the Amazon Web Services logo. So I'll open that up. And then it asks me to set details. Do I want to store it at reduced redundancy? So the default redundancy of S3 is 11 nines, which means out of the literally trillions of objects that have been uploaded, we don't lose those things. You could also encrypt it server-side if you were so inclined. That would mean that we are storing it using a double encryption system on our side. You also can set permissions for that file. So clearly I want to be in charge of this logo that I upload. But then the question is, can I get it out to the internet? So you can make that file public. Then we'd be able to read it from the web. I can also add more nuanced permissions around different grantees, and there's a lot of data here around exactly how to do that kind of thing. But for demonstration purposes, you just say, I want to make that file a public file. And then I'd start the upload, and it'll go mash, and done. Now this file is available. If I go to Properties, you'll see the URL that it made. So first is the place we put the bucket, US-West2, AmazonAWS.com, then the name of my bucket, Supremely Awesome Demolition, and then the logo Precious is the name of the file. So if I copy that URL, and look, I have something that shows pictures automatically, so it makes it super fast to see that it works. But if I, wow, that's hard. Oh, no, you don't get out of the way. Almost. I'm going to do it with my keyboard faster. No, copy it. Now if I go to a new URL up here, paste, and get rid of this part of it, and get rid of all this part of it here too. Now if I go, voila, there's the logo. Now, you can go, if you're listening along and you're fast with the browser, and you can type the crazy things that I type into the screen, you can type this on, and this is available to the internet now, live. Same as you could, frankly, with going back to this IP address before you saw it. So this logo here is now available to the web. It's stored at high durability, and I only pay for the storage of that individual file and the number of times that it's put or get. It's a thousandth of a penny to put a file and a 10,000th of a penny to get a file out of S3. So pretty powerful, pretty inexpensive, pay-as-you-go kind of way to get stuff online. So that's, oh, let's do one other quick thing just so you can see what it looks like. Let's say if I wanted to look at the permissions and say, no, let's not let everyone access that file. Now if I come back here and reload, it will say, no sir, access denied. You do not get to have that file. So very powerful, very rapid control management over the files that you have. So that's our demonstration today. There's a whole bunch of other bits in here talking about what it is that it would be if something like this blew up or didn't work right. But if you are interested in how any of these things that we just covered work, if some of this stuff I went through too dang fast, if you want to have any other questions about what it looks like to get a new AWS account set up or any of the other pieces, I'm really eager to hear your questions. So really consider this open season. Don't hold anything back. There are no products that are offline. So looking forward to your questions.
Excellent. Thank you, Miles. Appreciate the demo. Before we launch into the Q&A session with Miles, because we have some great questions to review, briefly want to ask a few poll questions from our audience. So let me launch the first poll question. If you could take a moment and complete this first poll question, we would greatly appreciate that. Awesome. Thank you very much. I'm going to move now to our next poll question. If you could take a moment and read through this poll question and answer for us. Thank you. Alrighty, and one last poll question, if you could, one moment. There you go, our third poll question for today. Alrighty. Thank you again for taking the poll questions. We will now start the Q&A. So Miles, we have some great questions that came from the audience today. First question that we received from Pratik is he's having trouble installing Image Gimmick or Image Magic, I can't quite understand that, on Amazon EC2. Any recommendations there?
Sure. Image Magic is just an application for manipulating images, very popular standard Linux, Unix tool. Image Magic is typically in some of the larger repositories, so you could install it using yum or apt-get. If you don't find it in the local repository or by adding the universe repositories for the given Linux build that you're using, you can also download binaries for Image Magic. Have those binaries installed. So that's something you just go to the web and search for Image Magic, have that file downloaded to your EC2 instance, typically by curling it or getting the file, and then you'd run either the RPM installation or the or other installation process. Those are all detailed by on the Image Magic page. Great.
Great. Thank you, Miles. Another question here, and I know that the audience, you did review this today, but good question around why is it a best practice to use a separate email from your standard Amazon account?
That's a great question. So when you use an Amazon account email address to create your AWS account, the two are now inextricably linked. So let's say, for example, like you create a startup and it's just you're the only developer, you're the owner and operator, and everything's going great. And you've bought a bunch of music and books and things that you like on AWS. You'll create, say for example, a new AWS account using your Amazon, the email address you've used for Amazon.com, and now those two are connected. If you want to give someone else total control over your AWS account, say you sell your startup to a business, that account has to stay under that same email address. And as a result, that means that you kind of give control of your books and your photos and your Amazon.com side account stuff to somebody who probably doesn't want that stuff, and it probably is frustrating for you. So better to keep those two accounts separate so that if you ever have to transfer ownership or control of your AWS account, that your Amazon.com account doesn't go with it.
Great. Thank you, Miles. Another question here from Eric. His question was, can you set a cap for the maximum chargeable?
Cap, or sometimes those are called a quota, or there are other rules there. Today with AWS, because the systems are under your control, you can turn on and off any one of the different utilities that you use on demand. You have all of the control to establish that kind of limit, but there isn't a little button in our user interface that says, don't allow me to run over $5. We've definitely heard that request, but there are some really interesting wrinkles about what would actually happen if we just turned things off without notice. Because if you imagine, like, say, for example, that EC2 instance, say you put your company's website on it. If we turned it off instantaneously above when it accrued an amount of charges above, say, the $5 mark or the $50 mark or whatever it would be, now your website's offline. You probably actually want a different set of behaviors where sometime earlier you get notified and there's a bunch of management around it. We haven't built any of those tools. Now, lots and lots of our customers, because all of this is API-driven, have. And there are lots of systems that allow you to create that kind of more cost-controlled environment. We built the utility part first so that it's easy to pay just for what you're using, and certainly recommend maybe setting not an alarm at the $5 amount if that's what you want to stop paying out, but set yourself an alarm at the $2 amount so you have time to get in there and make the changes required in a way that's safe, in a way that follows your actual company's needs rather than just arbitrarily pulling the plug.
Excellent. Thank you, Miles. Another question here from Broad. What if I want to allow multiple IPs from around the world?
Sure. So we were over here in the management console. I say back into EC2, and I say I want to create that, change the rules for that security group. Now that EC2 instance is still up and running. We haven't done anything to get rid of it. If I go over here to VPC security groups, in my security group, the one we're using, Launch 3, I have these 2 inbound rules. I can create additional rules, right? So I could open port 22 to, myriad different IP addresses. I put in, not that one, like, here's one I was using before. I said, this address, would make it 47, or, make it 72. I can add each of those rules. Higher range of 32 is probably better. And each of those different addresses then would have network connectivity to the instance. Now you still need security for that connection, so you'd have to share that SSH key or a different SSH key with every one of those accessing users. You still need the SSH key, by the way, for Windows users. It's just that the key gets used to decrypt the Windows administrator password. And that's all handled through our management console. No extra work there.
Excellent. Thank you, Miles. Another question here. The question is, say we have an existing, I think it's LAMP applications instance running on our own virtual environment. Is there any way to import it to AWS, or does it have to be rebuilt? And it's coming from a Mac Linux environment.
Yeah, Linux. So we do have a service for assisting with the import of the images into AWS. That system is called VM Import, creatively named. If you go to VM Import Export here, you can see a series of tools. You can do this from the command line. You can also install, if you're using vSphere, a VM Import connector for vCenter, which is pretty powerful. It just allows you to drive directly up into AWS. Now your instances have to be running certain different kinds of operating system software. There's details about that. And there are costs associated with running the import, which is just basically the computer that turns on our side to do the processing is an EC2 instance, and you're charged for the use of that instance, which is very inexpensive. So worth taking a look here at VM Import. It has details about that. Now, if your virtualization environment, or if you're building on bare metal, if you have a physical machine that's running LAMPstack, a nice trick is to use the physical to virtual conversion tools like VMware's P2V converter, and then once it's virtualized, then use virtual like a V2C or virtualization to cloud conversion, which the VM Import Export tool is. There are also third-party tools, things like Racini and others that help with this kind of import-export process.
Great. Thank you, Miles. We have a few questions around compliance and encryption. Basically, one here in particular is like, I need to store health data with high encryption. What are my best options?
Sure. So encryption is a best practice no matter what kind of data that you're using. And there are lots of different mechanisms to encrypt data. So we showed, for example, S3 has what's called server-side encryption, and access to files on S3 is done through SSL or connection encryption. So that pattern for storing files in an encrypted way in S3 is encryption on our side, but there's no reason that you shouldn't also encrypt the files before they get to us. So assuming every conceivable one of the security controls on our side is compromised, the files that are located with us are still encrypted by keys which you manage and control. There are lots of different ways to encrypt files. PGP works fine. If you're doing it for file systems, you can use things like TrueCrypt or DMCrypt or BitLocker for Windows tools, and then make images of those and send them to S3. There are also, you can use those same encryption tools for the disks or folders or files on EC2 instances. You might also want to take a look at encrypted root volume tools like from SafeNet or Trend Micro has tools for this stuff as well. But in any case, those encryption patterns should absolutely be a part of your solution design. We also have, speaking of the sort of healthcare stuff, we have a whole section of information about creating medical data applications with AWS that are HIPAA compliant. We have a whole PDF, a white paper that was written around those standards, and it also shows examples of applications that have been built to meet HIPAA compliance, like Disk Agent and C3 Health.
Okay, great. Another question here from Cheryl. When would it be best to use Elastic Beanstalk instead of creating EC2 instances on your own?
That's a good question. So we didn't really cover it. Elastic Beanstalk is a platform as a service built on top of AWS's infrastructure as a service. You can see it here in the little green box. When you go to Beanstalk, you offer a very different set of primitives. So what you're really building is an environment for hosting an application, not a server for doing whatever you want to do with. So the easy heuristic, the easy rule of thumb is if you are the author of the software that you want to run, you're writing a new PHP application, or you're writing a new Python application, or a Node.js application, or a Ruby application, or a .NET application. There's a whole bunch of different ones. You can actually see here, fun stuff, really fun stuff. It will probably yell at me because that was space. And I could say, the nice thing with the Beanstalk is it does do auto-scaling and load balancing. But you can see here I can make an IIS application, a Node application, a Java Tomcat application, whatever you feel like. So if you've written your own software, Beanstalk can make it very quick to get an application up and running. If you're running packaged software or something that you purchased, that probably runs on a server that you would configure to run it like on EC2. Hopefully that helps.
Great. One last question, Miles, we'll squeeze in here. Can you talk about AWS Platform as a Service offerings, and do we have such partners?
Sure. So not only is there the first-party platform as a service we were just talking about, Elastic Beanstalk, that allows you to run IIS or Node.js or PHP or Python or Ruby or Tomcat, there are also several platforms of service that are standalone startup companies which run entirely on top of AWS. So if you're a developer that's building Ruby applications, you can run those on top of Heroku. Heroku is a very popular platform for that kind of development. EngineYard is another platform that sits on top of us, very popular for running those kinds of applications. .cloud and Docker can run on top of us. Lots of other different OpenShift from Red Hat runs on top of us. So in those environments, a really unique benefit there. In each of those, you're still running inside of AWS. So the other services, all the rest of the stuff on this screen, that you want to build a platform-based application, but you want to reach back into a DynamoDB table, or you want to use Redshift, our petabyte scale data warehouse, you can connect to those services from something built either in Beanstalk, our platform as a service, or in anybody else's AWS-based platform as a service. And you're about a millisecond away from those applications instead of reaching all the way across the public internet to some other service way out in the world. So that can be a really cool pattern.
Great. Thank you, Miles. So I'd like to extend a special thank you to you, Miles, and especially to all of our attendees that could join us today. We had some great questions and some great content shared in this demo today. If you have any comments on our previous and upcoming webinars, or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcasts@amazon.com. Your feedback will help improve our webinar programming. Again, thank you everyone for joining us